Hello there. This is Amar Vishwanathan presenting the demo for a multimodal knowledge graph for deep learning papers on code on behalf of my colleagues at Siemens and UC Irvine. Now, this is going to be the demo outline. We'll first look into our motivation and the challenge, then our proposal to tackle this challenge, which is a large-scale scientific knowledge graph. We'll look into the system architecture and then two demos on a Jupyter notebook. Deep learning has been central today to any data-driven application. These models have been applied to almost all aspects of life: computer vision, NLP, robotics, drug discovery, digital assistance. The number of publications describing new DL models and applications grows very fast, and keeping up with these publications is a great challenge. Now, how do we tackle this challenge? We propose constructing knowledge graphs. We believe that a scientific idea is represented by multiple modalities: text, image, and code. We want to extract information from these modalities and represent them as a knowledge graph. Now, once you have a knowledge graph, you can have descriptive queries like the one shown here. We believe that this allows experts to look into deep learning models across conferences and papers. Here is our system architecture. Our system architecture takes as input a paper which is in a PDF format and the code repository. This then goes through three pipelines: text to graph, image to graph, and code to graph, which output atomic knowledge graphs. These knowledge graphs are then translated to RDF using our schema, which is a DCC schema, and an external ontology called the computer science ontology. This resulting aligned graph is then stored in a virtuoso triple store on which Sparkle queries are issued. Here are the repository links. You can find all the details regarding installation, files, data sets, and anything related to the project here. And then now let's get into the demonstrations. I'm going to end this slideshow and look at the demonstrations. The first demonstration is a paper to graph, wherein you're going to visualize a single paper as a knowledge graph. The first thing that you would like to do for this paper to graph is to provide URL links to its PDF and then the code repositories. We have provided them here, and then here is a single paper. The first paper that we are looking at is a point net VLAD. Now, this paper has at least one deep learning architecture here. Let us see whether this gets visualized. Now, here is the text to graph. You can see that there are entities and relationships. Once you click on them, you can look at the different entities. You can also see that they are mapped to an external ontology. Clicking on these nodes will give you more details. So the same happens for an image to graph. An image to graph, the figure is extracted. From these figures, there are different components of the figure that are extracted as normalization block, RNN block, and then you can see that this is also mapped to external ontologies. The same happens for code to graph. Now, code to graph is slightly big, so you can zoom in. Once you zoom in, you can see different aspects of the code to graph like batch normalizations, loss functions, and variables used. Finally, you can also see all the three graphs as a single merged knowledge graph and see the connections by zooming in and zooming out. This concludes the demonstration one. Now let us look at the second demonstration. For the second demonstration, we took in a lot of papers from our data set, which is papers to code, and then converted them into knowledge graphs and then stored them in a triple store. Now these queries are issued on that triple store. After the input modules are done, here is the first query. This shows the number of publications per year across all conferences. In the second one, you look at number of publications by conference series and year. This is what it shows. You see CVPR, ECCV, and other conferences. This is an interesting query, the third query, which shows PyTorch platform trends. As in people who are adopting PyTorch over the years, or papers which are adopting PyTorch over the year. The fourth query shows which functions have been used as implementations for the papers across these conferences. As you can see, for example, conferences like ECCV use range, conferences like CVPR use layers convolution 2D, conferences like NeurIPS use get variable and keras layers activation. Finally, we are going to look at the final query, which is about asking for papers which talk about audio processing using an attention mechanism. And in this case, here is a particular paper, which is an ECCV 2018 paper. These are just a sample of the queries that we have shown here. For a more wider set of queries, you can go look into our repository. And this concludes our demo. Thank you very much.